warehouse in Microsoft Fabric. So let's move ahead. Okay, there are two ways to query the data. Either we can use SQL Query Editor in Microsoft Fabric, so which is basically a versatile tool that support T-SQL, and it allow you to create and run scripts to query your data warehouse. It also provide features such as intelligence and debugging to aid in the development process. So T-SQL allows users, analysts, and developers to manipulate the data stored in a data warehouse. So to launch the SQL Query Editor, you need to select your warehouse asset from My Workspace, and this step connects to your data warehouse automatically without you having to prompt any connection information. So from the warehouse explorer, there are few ways to create SQL Query Editor that we have seen in our previous demonstrations as well, that either we can create a new SQL query from the home menu, okay, or from the queries node as well, okay. So we can select in my queries, and then we can select new SQL query. And also, yeah, now run queries and export result. So the query editor, it offers the ability to save your highlighted query as either a view or a table, each with distinct feature. So you can either save as view, which allow you to create a view in the warehouse using the select statement, which is highlighted in the query editor, or you can even save as table, which create a new table with the query with your query results. So for both the option, you must provide the schema and the name before confirming the creation. And the result section, it shows a preview which is limited to the 10,000 rows if exceeded. Then also your query result can also be exported as an Excel file. So this was about running the query and exporting the result. Now let's move on and explore the visual query editor. So this feature, we also observed it when we were performing our previous demonstration. So the visual query editor in Microsoft Fabric Data Warehouse, it is a tool that provide an intuitive interface for building SQL queries. All right. And it simplifies the process of writing and managing queries, especially for those who might not be comfortable with SQL syntax. So graphical, it provides the graphical interface where we can drag and drop the tables and visually design our queries, and this make it easier to understand the structure of your query and relationship between the tables. Also it as you designed your query using the visual interface, the corresponding SQL query is automatically generated. So it also provide automatic query generation. Okay, and basically this allow you to focus on the logic of your query rather than the syntax. And all the workspace users can save their queries in my queries folder. Now Using the SQL Server Management Studio to connect to a data warehouse in Fabric, it can facilitate your workflow, especially if you are already familiar with the tool. And in the Fabric service, we can navigate to the warehouse item, and then we select the settings, and then we can copy the SQL connection string. All right. So we can use our preferred SQL client tool, and this screenshot here, it shows SSMS and connect with appropriate authentication. All right. So in Microsoft Fabric, basically two types of authenticated user are supported through the SQL connection string. One is Microsoft Entra ID, and IDs, user principal or user identities, or Microsoft Entra IDs, service principal. Okay, and any third party tool can use the SQL connection string via ODBC or OLE DB drivers to connect to a Microsoft Fabric warehouse or SQL Analytics endpoint using the Microsoft Entra ID authentication. So this was about connecting with SQL client. Now let's move on. Okay, so aggregate measure. Now, most data analytics with a data warehouse involves aggregating numeric measures in the fact tables by attributes in the dimension tables. Okay, so because of the way a star or snowflake schema is implemented, queries to perform this kind of aggregation basically relies on the join clause to connect the fact table with the dimension tables, add a combination of aggregate functions and group by clauses to define the aggregation hierarchies. Okay, so this is the output of this query, which is joining the fact sales table and dimension date table, and this is grouping the data by calendar year, okay, and calendar quarter, and then this also ordering the data. So let's look at its output. So the output is showing total sales by year and quarter. Okay, so here we can also join in a snowflake schema, and again here we are joining the dim product and fact sales table along with the dim category table, and we are grouping it according to the product category. All right, so let's see what is the output of this. So output shows the item sold by the product category. Then we can also use the ranking function. All right. So these function, it enable us to partition the data over categories, and each returning a specific value that indicates the relative position of each row within the partition. So row number returns the ordinal position of the row within the partition. For example, the first row is numbered 1, the second as 2, and so on. When we talk about the rank, so it returns the ranked position of each row in the ordered result. For example, in a partition of stores ordered by sales volume, the store with the highest sales volume is ranked as 1. Okay, and if multiple stores have the same sales value, they will be ranked the same, and the rank assigned to the subsequent store, it reflects the number of stores that have higher sales value, including ties. And then we have dense rank function. So this dense rank ranks the rows in a partition the same way as rank. But when multiple rows have same rank, then subsequent rows are ranking positions, and it ignores ties. Then we have entile. So it returns the specified percentile in which the row falls. For example, in a partition of stores ordered by the sales volume, entile 4 returns the quartile in which a store sales volume places it. So let's look at the result of this query where we are using the ranking functions like row number, rank, dense rank, and entile. So we are getting the output where which is grouped by category and relative rank. So we can see the rank of accessories for where the product category is accessory and product name are different and they are arranged according to their ranks. Dense rank is also shown here, quartile is also shown, and row number is also shown. Okay. So basically, the sample result is demonstrating the difference between the rank and the dense rank. Okay, so if we note that in accessories category, uh, this sprocket and Duda product, they have the same list price and are both ranked as the third highest product. Okay, the next highest price product has a rank 5. There are 4 products more expensive than it and a dense rank of 4. That means there are 3 higher prices. All right. So, with this slide, we also have come to an end of our third topic. Now we will move forward towards our